All right, so this should be a nice, quick and easy summary of log functions and some important transformations. So let's start with the basic one. If we have log base 2 of x, and I mentioned this before. Here, let me scroll down so you can see it. I mentioned this before, but usually you have a default base of 10. But if we worked with 2 to the x last time, I wanted to have a base of 2 for it to be a true inverse. But yeah, you can have any base that you want. And so number 1 is referring to intercepts. The intercept for this one is going to be 1, 0, which would make sense because if we had an answer of 1, and remember, I like to think of my x as the answer and my y as the exponent. If we had an answer of 1, what is the exponent that would have got us there? And the answer would be 0, because anything to the power of 0 is just going to be 1. So that is that intercept, which is different from exponential because we had a y-intercept of 0, 1. So we basically just flipped it. And then domain and range for inverses, you just flip them again. So that is what we're going to do. All right, let's do this in green. So for our domain, remember that our range for exponent was, for exponential, I mean, was from 0 to infinity. And so that's what our domain is going to be. Which makes sense because when it comes to exponential functions, unless you do some transformations, you're not going to get anything negative. So that's from 0 to infinity. And then for range, it's a little bit tricky, but if you look on the graph here, we have this vertical asymptote on the y-axis. And so you're kind of tempted to think that like there are restrictions there, but you see that the curve just follows that asymptote all the way down. So it's really from negative infinity to infinity. And if you're ever wondering how I'm getting the range, I'm really just looking at the extremes of the curve and trying to figure out where the graph is going. That's just what I do. But for number 4, so where's the graph positive and where is it negative? I can already see where it's negative. So we have that asymptote at x equals 0. And you can see that the curve is below the x-axis at that point. So from 0 to 1, our curve is going to be negative. And you can see that on the graph here, how it's like approaching negative infinity when it's getting closer to the 0. And then at the 1 here is where it crosses the x-axis. So that's going to be from 0 to 1. And then positive is just going to be everywhere else. So 1 to infinity. And then, of course, when you're doing this, always take into account that domain. So we're not going to be referring to negative infinity because there is no negative infinity when it comes to our x values. All right, and then increasing and decreasing. Let's use our tangent lines. I'll do that in red. So if I draw my lines on here, we can see that I start out pretty positive, and then it doesn't really stay super positive, but the slopes are still positive. So we would say that it is increasing. Concavity is going to be concave down like a frown, and we can see that because our actual slopes are getting flatter, so they're decreasing. But the slopes themselves are positive. So the graph is increasing, but the rate of change is decreasing. I know that's a little confusing. You can just do concave up like a cup, concave down like a frown. And then for number 7, end behavior, this is a little bit tricky because, again, we don't want to do x goes to negative infinity. That doesn't exist for logs. So instead, here's how you would write it in limits, if this makes any sense at all. So if we have x approaching 0 maybe, and then if we want to say either from the right side or the left side, we do a positive or negative sign. So in this case, it's from the right side. So our curve is approaching this vertical asymptote from the right side. So that's one way of writing it. And then we would write log base 2 of x. And so when it approaches that 0 from the right side, our y values are going to go to negative infinity. And so that's one way of writing it, if it makes sense at all. If you don't want to do it that way, you can just kind of ignore the negative infinity and behavior. But as x, we'll do that. As x approaches positive infinity, which it can do, y is also going to approach positive infinity. And we can see that on the graph. And we already answered asymptotes. That's just going to be vertical at x equals 0. Now let's do transformations. Again, these were the ones I thought were the most notable. So let's say you had a number out in front that is either greater than 1 or less than 1. So if it's greater than 1, then the graph is going to stretch. And so you can see that with the green curve right there. So the golden is our original. The green is greater than 1. So it just kind of becomes taller, basically. And if you have a fraction, so if we have 0.5, you can see that in the pink right there, then it just becomes like lower and closer to the x-axis. All right, and then so what if we had a plus whatever or minus whatever in the argument itself? And I actually wrote natural log here, and I just want to point out that that's the same as log with a base of e. It's just another way of writing that. And I'll explain that a little bit more in the applications video. But anyways, so as always, I like to box in the numbers that end up changing with this transformation. So the intercept is definitely going to change because our 1, 0 is going to move left 5, and that's going to give us the negative 4, 0. Number 2, domain. So we used to just plug in between 0 and infinity, but now we have that plus 5 that kind of changes things. And so really, we can plug in anywhere from negative 5 to infinity, because negative 5 plus 5 is going to give us that 0 mark that we had before. And you can also see that on the graph that we don't have any curve that is left of that asymptote. And then for range, that's going to stay the same, negative infinity to infinity. Positive and negative is going to change with that domain. So let's start with negative. So this is x equals negative 5. I should write that. And so it's going to be negative from negative 5 to negative 4. Kind of like our 0 to 1, but now we moved it left 5. And then positive, running out of room, going to do a crazy arrow. Positive everywhere else, so negative 4 to infinity. The graph is still positive. We still have some positive slopes there, so that's still increasing. Concavity looks the same. The graph didn't really change all that much. And skipping number 7, going to number 8, asymptote obviously going to change. We moved from x equals 0 to x equals -5. Okay, so you might be wondering, because we shifted it left, does the end behavior change? And the answer is no, um, because first of all, x doesn't approach negative infinity, so we can ignore the left. And if we look at the right side, even though we shifted it left a little bit, that doesn't really mean a whole lot in the grand scheme of things, because as x goes to positive infinity, both of these graphs are still going to approach positive infinity as well. So um, yeah, when you're just kind of like adding or subtracting these small numbers, or even big numbers, that doesn't really compare to numbers like infinity. So those horizontal shifts don't affect end behavior, basically. Um, it would affect our limit if we did that thing right there. Um, then instead of the 0, we would have the -5. But I'm not going to do that again because I have a feeling that you don't like seeing it written as a limit. Okay, and then just some quick reminders. So the golden is our original function here. If you have a negative x, that is a reflection over the y-axis. And you can see that on the graph, how it reflects that way. And that's because if we're switching all of our x values, then we want to move the graph to the negative x. So it seems counterintuitive, but you just want to think about what is actually flipping. And it's going to be the x values. So you need to like move it over the y-axis to get it negative in the x direction. And then if we have a negative out in front, that's going to be a reflection over the x-axis. And again, that's just because if we're multiplying all of our answers by -1. So that's going to change all of our y values. And the way we can show that on the graph is by flipping the graph over the x-axis. So yeah, that's pretty much it. And I think that the next episode will be log properties. So I hope you join me for that.